This question says the demand for an item is 6,000 units per year. Its production rate is 1,000 units per month. The carrying cost is rupees 50 per unit per year, and the setup cost is rupees 2,000 per setup. The shortage cost is rupees 1,000 per unit per year. Find the various parameters of this system. Various parameters in the sense we need to find out the EBQ, economic batch quantity, and maximum shortage, maximum inventory, and then cycle time, etc. All those aspects. So first of all, let us capture what is given in the question. It says demand for the item is 6,000 units per year. That means capital D is 6,000. Production rate is given as 1,000 units per month. We need to convert this into year. So I will multiply it by 12. So to make it 12,000 units per annum. Then the carrying cost CC is given as rupees 50. And then setup cost CO is given as rupees 2,000 per setup. And then shortage cost CS is given as rupees 1,000 per unit per year. So definitely this is a manufacturing model because they gave us the production rate, number one, and then they also gave us the setup cost. Since shortage cost is given, that is, it means that this model is manufacturing inventory model with the shortages. So we already derived earlier in our earlier video how to derive economic batch quantity and maximum shortage we arrived at. So based on that, we will have the optimal values for this model as follows, which is T star. These are the parameters what we are going to calculate. T star is Q star divided by D. T1 star is IM star by K minus D. T2 star is IM star by D. T3 star is SM star by D. And T4 star is SM star by K minus D. Then we have maximum shortage, which is 1 minus D by K times Q star times CC by CS plus CC. And then our economic batch quantity will be EBQ, which is Q star equal to square root of 2 times DCO divided by CC multiplied by 1 divided by D minus D by K times CS plus CC divided by CS. And then inventory maximum can be evaluated as economic batch quantity minus the maximum shortage. So first thing is we will evaluate EBQ. Q star we will find out. Substituting the values, whatever we have, it is 2 times D. What is D? D here it is 6,000 times CO. CO is 2,000 divided by CC. CC is 50. And then we have 1 divided by 1 minus of, I think we can evaluate this separately. 1 minus D by K will be 1 minus of 6,000 divided by K, converted K will be 12,000. So which is actually 1 minus of 1 by 2, which will become 1 by 2 only. So 1 minus of D by K is 1 by 2. Straight away we can substitute that here. So here we have 1 divided by 1 by 2. And then CS. CS is 1,000 plus 50. 1,000 plus 50 divided by 1,000. All these things within the square root. Now if we calculate this, we get 1,004 units approximately. Now we can proceed finding this SM, that is maximum shortage. Let us substitute it. We have this 1 minus of D by K as half. So we have half times. Here we have Q star, which we already calculated, 1,004. 1,004 times CC. CC is 50 divided by CS plus CC, that is 1000 plus 50, we get 1050. If we calculate this, we will have 24 units. Let me recheck this. 1004 multiplied by 50 divided by 2 divided by 1050. Yes, it is approximately 24 units. So we got EBQ, we got maximum shortage. Now let us calculate this maximum inventory, which will be EBQ, that is 1004 minus 24. If we calculate that, oh, sorry, here it is not 1004. It is half times because 1 minus d by k is also there. So we have half times because 1 minus d by k, we already know it is half times 1004 minus 24. Means this becomes 502. 502 minus 24, we get 478 units. Now let us calculate the other things, that is T star. We have T star is Q star, which is 1004 divided by D. D is 6000, which means our T star will be, if I convert this, I mean, first let me divide directly and write it in year, in terms of year. 1004 divided by 6000, we get 0.1673 year. And approximately, if you convert it into days, we get 61 days. Then our T1 star will be IM star. IM star, we already calculated it as 47. So it is 478 divided by K minus D. What is K minus D? K is 12,000 and this is 6,000. So that is also 6,000 only. This will give you in terms of year, 478 divided by 6,000. We get 0.08 year. And we'll convert it into days by multiplying it by 365. We get 29 days. Then T2 star will be IM star, that is 478 divided by D. D is also 6,000 only. So we will get the same, which is approximately 29 days. Then T3 star will be SM star. SM star is 24 divided by 6,000. And let us directly convert it into days. 24 divided by 6,000. Whatever we got, we multiply it by 365 to get 1.46, means I will say 1.5 days. Then T4 star will give SM star, which is 24 divided by 6,000, which will also give you 1.5 days. Now we can verify by adding all this T1 plus T2 plus T3 plus T4, are we getting T star? We can see that 29 plus 29, it is 58. 58 plus this 2 together is 3. 58 plus 3 becomes 61. So we got the T star tallying with the T1 star plus T2 star plus T3 star plus T4 star. So that is the solution. These are the various parameters for this inventory model, and this is the solution.